what even is a fractal anyway?
A fractal is an infinitely complex shape created by endlessly repeating a pattern or function. As you zoom into the fractal, the pattern keeps appearing again and again, which leads to some really hypnotic shapes.
Ooh.
Long before mathematicians worked with fractals, nature was creating them. Let's go to the kitchen to find out more. Broccoli is an example of a natural fractal. If you see here, the broccoli is made of the stem with a lot of smaller florets. Then, if you look at one of these florets, the floret is made of a stem as well, with even smaller florets on top. And if you zoom into these subflorets, you will see that it is also made of a stem with even smaller florets. Other examples of fractals in nature include snowflakes, weather patterns, and even river deltas. Around 1975, mathematician Benoit Mandelbrot coined the term fractal to describe the infinite shapes previously discovered by that time, such as the Koch snowflake, the Sierpinski Triangle, and his own iconic Mandelbrot set. By applying mathematical theory to nature's beautiful creations, Mandelbrot opened the door to representing previously hard-to-describe patterns through fractals. The theory behind fractals is a mathematical idea called recursion, which is a problem-solving approach where you take the problem and break it up into smaller and smaller pieces. In practical uses, there are two main parts. First is the recursive case, where you call a pattern or function again and again, but on increasingly smaller parts. Second is the base case, which is a set value where the recursion knows when to stop. As the number of recursive calls goes to infinity, the pattern becomes an infinite fractal. Let's look at the Sierpinski triangle to learn more about this. The base case, level 0, is just one filled-in triangle. By performing a recursive call, the triangle is split into 4, where the corners are now level 0 triangles and the middle is unfilled. Then, with level 2, each of the previously filled-in corners become level 1 triangles, while the middle remains white. As the levels, aka recursive calls, increase, the triangle becomes the infinite Sierpinski triangle. Pretty cool, huh? Today, fractals are being used in a variety of fields, from modeling brainwaves, to understanding soil erosion, to even improving our telecommunication. Now that you know a little bit about fractals, see if you can spot them all around you.